Determining the number of 115 volts 15 amps receptacles allowed on a 20 amps breaker involves understanding the National Electrical Code, or NEC, and applying some basic electrical calculations. The NEC provides guidelines to ensure electrical safety and prevent overloading circuits. Firstly, it is important to know that the NEC does not explicitly state the maximum number of receptacles on the circuit. Instead, it focuses on the total load connected to the circuit. The load calculation is based on the volt-ampere rating of the devices connected to the receptacles. Secondly, a general rule of thumb is to limit the load on a circuit to 80% of the breaker's capacity. This is to prevent nuisance tripping of the breaker and ensure safe operation. In this case, a 20 amps breaker at 115 volts has a total capacity of 20 amps times 115 volts, which equals 2300 volt amps. Taking 80% of this capacity gives us 1840 volt amps as the maximum allowable load. Thirdly, each 15 amps receptacle is typically rated at 180 volt amps, as per NEC guidelines for general use receptacles. This rating is used for load calculations regardless of the actual load connected to the receptacle at any given time. To determine the number of 15 amps receptacles allowed, we divide the maximum allowable load, which is 1840 volt amps, by the volt-ampere rating of each receptacle, which is 180 volt amps. This gives us 1840 divided by 180, which equals approximately 10.22. Since we cannot have a fraction of a receptacle, we round down to the nearest whole number. Therefore, you can safely install 10 receptacles on a 20 amps breaker. However, some local codes or specific applications might require a lower number of receptacles per circuit. It is always best to consult with a qualified electrician or local electrical inspector to ensure compliance with all applicable regulations. In addition to the 80% rule, it's also important to consider other factors that could affect the circuit load. For example, if the circuit is used to power lighting fixtures or other appliances, the total load of those devices must also be included in the calculation. If the total load exceeds 1840 volt amps, then you would need to reduce the number of receptacles on the circuit or install a separate circuit for the additional load. Another consideration is the type of load connected to the receptacles. If the receptacles are used to power heavy-duty equipment or appliances that draw a large amount of current, then you may need to reduce the number of receptacles on the circuit to prevent overloading. For example, if you are using the receptacles to power tools or other equipment that draws 10 amps or more, then you may only be able to install a few receptacles on the circuit. It's also important to note that the NEC has specific requirements for receptacle spacing in certain areas, such as kitchens and bathrooms. These requirements are designed to ensure that receptacles are conveniently located and that there are enough receptacles to meet the needs of the users. In kitchens, for example, receptacles must be installed at least every 12 inches along the countertop. In bathrooms, receptacles must be installed within 3 feet of the sink. These requirements may affect the number of receptacles that you can install on a circuit. In summary, the number of 115 volts 15 amps receptacles allowed on a 20 amps breaker is generally limited to 10, based on the 80% rule and the standard volt-ampere rating of receptacles. However, it's important to consider other factors such as the total load on the circuit, the type of load connected to the receptacles, and any applicable code requirements. Always consult with a qualified electrician or local electrical inspector to ensure compliance with all applicable regulations. Here's a more detailed breakdown of the calculations and considerations. Firstly, calculate the total circuit capacity. A 20 amps circuit at 115 volts provides 20 amps times 115 volts equals 2300 volt amps. Secondly, apply the 80% rule. To avoid overloading, limit the continuous load to 80% of the breaker's capacity. This means 0.80 times 2300 volt amps equals 1840 volt amps. Thirdly, determine the volt-ampere rating per receptacle. The NEC typically assigns a load of 180 volt amps per general use receptacle. Fourthly, calculate the maximum number of receptacles. Divide the maximum allowable load by the volt ampere rating per receptacle. 1840 volt amps divided by 180 volt amps per receptacle equals approximately 10.22 receptacles. Round down to 10 receptacles. Fifthly, consider specific load requirements. If you know that certain receptacles will serve specific loads, calculate those loads individually and subtract them from the available capacity before determining the number of remaining receptacles. For example, if one receptacle is dedicated to a device that draws 500 volt amps, subtract that from 1840 volt amps, leaving 1340 volt amps available for other receptacles. In this case, 1340 volt amps divided by 180 volt amps per receptacle equals approximately 7.44 receptacles. Round down to 7 additional receptacles. Sixthly, address continuous loads. If any devices connected to the receptacles are considered continuous loads, meaning they operate for 3 hours or more at a time, ensure that the circuit is only loaded to 80% of its capacity, including those continuous loads. The calculation remains the same, but it's a crucial factor to keep in mind. Seventhly, consider multi-outlet assemblies. Multi-outlet assemblies, or power strips, are often used in commercial or industrial settings. Each 5-foot section is typically rated at 180 volt amps. The number of receptacles in the assembly does not matter, it is the total load in the assembly that needs to be considered. Eighthly, inspect for shared neutrals. Shared neutrals, or multi-wire branch circuits, can affect the load calculation. If a circuit shares a neutral with another circuit, the neutral conductor must be sized to carry the maximum unbalanced load. This can impact the number of receptacles that can be safely installed on the circuit. Ninthly, examine dedicated appliance circuits. Some appliances, such as refrigerators or microwave ovens, require dedicated circuits. These appliances should not be connected to the same circuit as general use receptacles. Tenthly, factor in local codes and amendments. Local codes and amendments can vary from the NEC. It is important to check with your local building department to ensure compliance with all applicable regulations. This may include restrictions on the number of receptacles allowed on the circuit or specific requirements for receptacle spacing. 11thly, always consult a qualified electrician. If you are unsure about any aspect of electrical wiring, it is always best to consult with a qualified electrician. An electrician can assess your specific needs and ensure that your wiring is safe and compliant with all applicable regulations. This is especially important if you are working on a renovation project or adding new circuits to your home. To clarify further on receptacle spacing, firstly, general requirements. The NEC specifies requirements for receptacle spacing in dwellings to ensure that cords of lamps and appliances can reach a receptacle without exceeding 6 feet. This is known as a 6-foot rule. Secondly, wall space. Receptacles must be installed so that no point along the wall line is more than 6 feet from a receptacle. This applies to both horizontal and vertical wall space. Thirdly, countertop spacing. In kitchens and dining areas, receptacles must be installed along countertops so that no point along the countertop is more than 2 feet from a receptacle. This is to ensure that small appliances can be easily plugged in. Fourthly, island and peninsular countertops. Island and peninsular countertops that are 12 inches or wider must have at least one receptacle. If the countertop is 24 inches or wider, it must have at least 2 receptacles. Fifthly, bathroom requirements. In bathrooms, at least one receptacle must be installed within 3 feet of each sink. This receptacle must be GFCI protected. Sixthly, outdoor receptacles. Outdoor receptacles must be GFCI protected and must be located in a weatherproof enclosure. The number of outdoor receptacles required depends on the size and layout of the property. Seventhly, appliance receptacles. Receptacles that serve specific appliances, such as refrigerators or washing machines, must be located within 6 feet of the appliance. Eighthly, basement receptacles. Basements must have at least one receptacle. If the basement is finished, it must have receptacles spaced according to the general requirements for dwellings. Ninthly, hallway receptacles. Hallways that are 10 feet or longer must have at least one receptacle. Tenthly, stairways. Stairways must have a receptacle at each landing. 11thly, code variations. Local codes may have additional requirements for receptacle spacing. It is important to check with your local building department to ensure compliance with all applicable regulations. Additionally, consider the following on GFCI and FSI protection. Firstly, GFCI protection. Ground fault circuit interrupter, or GFCI, protection is required in certain areas to protect against electrical shock. These areas include bathrooms, kitchens, garages, and outdoor locations. Secondly, FSI protection. Arc fault circuit interrupter, or FSI, protection is required in bedrooms to protect against electrical fires. FSIs detect arcing faults, which are a common cause of electrical fires. Thirdly, dual function breakers. Dual function breakers provide both GFCI and FSI protection. These breakers are becoming increasingly popular as they offer comprehensive protection against electrical hazards. Fourthly, testing requirements. GFCI and FSI devices must be tested regularly to ensure that they are functioning properly. Test buttons are provided on the devices for this purpose. Fifthly, code compliance. GFCI and FSI protection requirements vary depending on the location and the electrical code in effect. It is important to check with your local building department to ensure compliance with all applicable regulations. Sixthly, retrofit requirements. In some cases, GFCI and FSI protection may be required when renovating or remodeling a home. This is to ensure that the home meets current safety standards. Seventhly, surge protection. Surge protection is recommended to protect electronic devices from voltage spikes. Surge protectors can be installed at the service entrance or at individual receptacles. Eighthly, grounding requirements. Proper grounding is essential for electrical safety. All electrical circuits must be properly grounded to provide a path for fault current to flow back to the source. Ninthly, wiring methods. The NEC specifies the acceptable wiring methods for different types of installations. These methods include using conduit cable and surface raceway. 10thly, conductor sizing. Conductors must be sized appropriately for the load that they will carry. The NEC provides tables for determining the appropriate conductor size based on the amperage and the type of insulation. 11thly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overload and short circuits. These devices must be sized appropriately for the circuit that they are protecting.